Let's take a look at fluorine as another example. Fluorine is in group 7A, so it has 7 valence electrons. Originally, fluorine has 9 electrons total. So it has 9 electrons and 9 protons. However, if you look at this dot diagram, it has one empty spot for the electron. So fluorine would easily gain one more electron and form the full octet like this. So as a result, the total electrons that fluorine will have after gaining the electron is 10 electrons. But the number of protons don't change. It is still 9 protons, but it gains one more electrons easily. So in the end, you end up with 9 plus charges and 10 minus charges. If you sum it up, it'll give you -1 charge. So the fluorine easily becomes an ion that has -1 charge. So this one shows how you can write it. So fluorine with -1 charge, or you can simply write fluorine negative. So if you see no number, but just a sign negative or positive, it implies that it's one, -1 or +1. Okay, so sodium is another example. Sodium has 2 electrons in the smallest shell and 8 electrons in the second shell and 1 electron in the outer shell. So we say that sodium has 1 valence electron. Now that 1 valence electron will make the sodium very unstable. So sodium will easily lose that valence electron, and it becomes a +1 charge because sodium has 11 protons, but after losing 1 electron, it ends up with only 10 electrons. So 11 plus and 10 minus makes +1 charge ion. So when we write the sodium ion, we write it like this, Na plus or Na plus 1. Magnesium, on the other hand, have 2 valence electrons. So it easily loses those 2 valence electrons to become more stable, and it becomes magnesium with +2 charge. And as you see it here, +2 comes from the fact that it has 12 protons, but after losing 2 electrons, it has only 10 electrons. So plus 12 minus 10 totals out to be +2.